Hey.
Yes. Battery seems
I believe you're going to want me here in a minute to do the whole presenting thing.
Yep.
The laptop is working.
The laptop is working. No.
I should have to. I would have to.
Just have to switch the screen here to.
Has to be one of those. No one's sharing.
Oh no, you're right. I stopped the sharing.
Maybe, yeah, you should.
Make sure it works.
That looks quite functional indeed. Very good.
You're everywhere. Right. So you're gonna have to do this.
Yeah, I think that. Yeah.
Michael, do we need a briefing? Whose computer is he?
Matt?
Matt.
Sorry.
I will go and check. Probably his own, but let me check.
Yeah.
And it already has
He's got Zoom installed. I can give him details.
He's already got it.
Yeah. But
So
it's just the details that do.
Yeah.
The details.
Yes.
That's easy.
Lovely speaking first, so we've got time.
Yeah, I'll do. While she's talking, I'll get him set up. Cool. I think that's. I'll leave it up to you. Want to call to order?
Hello, everybody. It is on the half hour, so it is time to get started. If you want to terminate your conversations, grab any more drinks that you think you might need, and sit yourself down, we will give everyone a couple of minutes to get settled, and then we will kick everything off. As this is your laptop, I fear I may need some assistance here. It appears that it's decided that it doesn't want to actually run the slides, which is rather good. There we go. Yes. Just, yeah. Or the arrows. See, I could probably have fixed that myself, but given that it's not my laptop, I can also just make someone else do it. So, hello, welcome to edition number 140 of the Melbourne AWS user group. We really have been doing these for a while, haven't we? The reason why I'm up here rather than one of the other organizers is because this is my last one. So, hello and welcome. It is good to have you all here. And to begin with, we would like to acknowledge the Wurundjeri people of the Kulin Nation, who are the traditional owners and custodians of the lands on which we meet today. We would like to pay their respects. Pardon me. It's been a long week. We would like to pay our respects to their elders, past and present. For any of you who've not been here before, or for any of you who have been here before and just want a reminder, we do have a code of conduct. You can read through the code of conduct at the link there. The short version is up on the screen. The shorter version is just be good to each other. If you think that there might be any problems with the code of conduct, if you would like to let any of us know that there are any breaches, you can find us on Slack, or you can find the people with the AWS user group leader, Polo. So me and the other three, Ian, Matt, and Jason are down the back there. We are all over the internet. We have a website. And this is freaked out on me again. Ian, your laptop's having fun. I need assistance again, sorry. Might be better if you just stand here so you can bonk it every time it freaks out.
I don't know why it's been difficult.
I don't know why it's being difficult either. I'm barely touching the keyboard. Anyway, as I was saying, we are on the internet. Our website is up there. We are on LinkedIn. We've put Twitter/X in the dustbin. So if you want to find us on the tweet-like medium, Mastodon at AWS Melb at awscommunity.social. Also the YouTube channel, AWS Melb, which is where you will be able to find the recording of tonight's session as well. This is where we stream all of the sessions. So the agenda for tonight, I don't know what's going on either. It's having, okay, so it's command, yeah, it's a Mac, of course it's command tab. What am I doing? So the agenda, introductions, this is me up here, then I will hand over shortly to these lovely gentlemen for the What's New in AWS section. And we have two wonderful speakers tonight. Lovey Jane will be talking to us about setting up CloudFront for active global architecture with latency-based routing, which is great because I've done presentations on disaster recovery. You should listen to her. This is going to be really valuable. And then for something a little bit different, the wonderful Matt Mariel, who is sitting down the back typing on his laptop, is going to talk to us about his AWS-powered R2-D2 astromech. What could possibly go wrong? Stay tuned. And then, as per usual, after the presentations, we'll have our marketplace segment. If you are looking for a job, we will not ask you to put up your hand and say you're looking for a job with your boss sitting next to you. We'll have everyone whose workplace is hiring come up and do their elevator pitch, and then we will shut down for the night. Please ask us questions. You can ask questions at the end of... This is getting really old. You can ask questions at the end of sessions by putting up your hand. In a minute, I get handed over to these two and they can deal with it. Putting up your hand at the end of sessions in the hashtag Melbourne channel on Slack or in the YouTube chat, and we will relay the remote questions then to the speakers. We could not put these events on without the help of our sponsors. A gold sponsor for this year is Mantel Group. Silver sponsor for this year is Civo Australia. And also thank you to NAB and the erstwhile Daniel for making sure that we actually have a venue every month to put these on. Again, you can find us on Slack. The link is up. The link is up there. We have many different channels. If you're interested in volunteering, you can come and find us on Slack. If you're looking for a job, or if you have a job and you're looking for people, there's a jobs channel for that. There's also the AWS outages channel, which tends to get very noisy around particular times of the year. And we are always looking for more people to get involved. So sponsors is something that we are looking for in particular, more sponsors. Matt is the money man down the back if you are willing to sponsor or you know someone who might be. We could not put these events on without our speakers. We would like to think, generally, this is a pretty friendly place for first-time speakers. If you've never done it before and you want to, we are always happy to help you. And we have talks which are everything from, hey, I just started playing with AWS and I did a thing, to absolutely 400 level stuff. However difficult it is, we are happy to have you. Sometimes the best talks are the ones where people just go and they play around with something and then they come here. There is always something that someone can learn from you. There is always someone who wants to learn more, no matter how basic it might seem to you, there's always someone that can learn from it. We also could not put on these events without our volunteers. We're always looking for people there. Again, come and find us on Slack. Events that are coming up. There's a small conference called AWS reInvent, which is happening in early December in Las Vegas. Is anyone going to reInvent? Good. I don't have, from my one experience of it, I don't recommend it. You can learn anything. You can learn everything that you need to know from the videos that will be published later online. Lots of walking, lots and lots of walking if you do ever happen to go. We also have the AWS Community Day Brisbane in August of 2025. So if anyone fancies a trip up to Queensland, that is something that is happening. I imagine probably more details closer to the date. Closer to home, we have the AWS Melbourne Well-Architected Meetup. If you think that Lovey's talk is great and you want to see it again, come and see her give the talk at the AWS Melbourne Well-Architected Meetup on the 18th of September. Level 13 at 555 is Mantle Group, yeah? No. Oh, that's AWS. I'm sorry, I forget which is which. And the serverless meetup is on the 19th of September, talks to be determined. If you are interested in giving a talk and you're into the serverless type things, the people who run the serverless meetup are absolutely great. If you want to learn about serverless, it's always a good place. So go down there. That one is at Mantle Group. That's the Flinders Street one is Mantle Group. And now I shall hand over to Arjen and Jason to do what's new in AWS.
Thank you, Dawn. Cool. So it's always lots of new stuff, or maybe not so lots, because it's starting to get that quiet time. Do we have new things in Melbourne?
Yay! Finally.
AWS Fast Snapshot Restore. I think this is something you've talked about before.
No, not really. But this, like, Fast Snapshot Restore is good if you do need to restore EC2. You have that enabled, then yeah, it comes back quicker. But I mean, AWS, EC2 snapshot restores pretty quick anyway. So yeah, you know, your mileage varies.
And on the Sydney side, we've got the Connect Contact Lens GenAI powered agent performance evaluations, which is a whole mouthful and in preview.
We know why it's in there because Matt loves AWS Amazon Connect. It's probably about the only person that's dealing with that, unless you do a lot of things with a contact center.
Yeah. Cool. Moving on to other things. First one here is pretty good. So Graviton-based instances now support Hibernation. Hibernation is the special, we all know what Hibernation is for our laptops and home computers. AWS has supported that for a long time as well on their instances, but not yet for Graviton-based instances, which are obviously the best instances to use if you have a workload that supports.
If you can run on Graviton, then yes, great, cheap, fast, low power. But yes, not everything is ARM-based. But
yeah, more and more will be. I mean, our laptops are these days.
A little bit of love for Lightsail, which is surprising. Yeah. I mean, some people that use it, but yeah, if you use Lightsail, a couple of extra goodies. The last one was I found was a bit interesting. Reachability health checks now for EBS volumes attached to your EC2s. So I'm guessing it must have happened somewhere, but I mean, I have very rarely seen any issues with EBS. So, but at least if your EBS goes kaput,
you'll know.
Yeah.
Or at least it will be in the EC2 status checks. On the container side, I think the big one here is more likely to be Carpenter 1.0. Carpenter is the AWS developed auto-scaling solution for Kubernetes containers. Well, for the instances and the horizontal scaling bit. My understanding is this is also easy to have on regular non-EKS clusters, since it's open source, more managed by Kubernetes now than AWS, which is nice. I haven't used it myself, but we've had several talks about it here in the past.
Yeah, I think previously it's sort of been in like preview type phase. So it's like, yeah, it worked, but not like sort of officially spotted. But I think the 1.0 is the big thing. It's like, yes, it's out of preview. It's now a thing. So yeah, that's probably the big one. I was reading up the basic scanning. The info on that was, hey, we do better scanning now. And that was about the extent of it. Which is always good. Better scanning is good.
Mm-hmm. And the slight improvement. So yeah, to make your life easier, you can restart containers now without having to relaunch a whole task in ECS. That's nice because it was a bit of a hassle. This is easier. There's machine learning stuff. Who knew? Who knew this as well? Just with that.
Tell me out.
Cool.
More stuff.
Basically, yeah.
Yeah.
One interesting one here, though, for anyone interested in using Q Business, which personally I see basically as Party Rock for Enterprise. It has the same interface, except it looks differently. It works the same way and it has some extra connections. But as it's not available in Sydney, and you have to tie it to your SSO, sorry, IAM Identity Center. You couldn't use it in Sydney. Now, if your SSO is in Sydney, now you can. Just keep in mind that will mean that it's running in the US, most likely. If the data you want to use has sovereignty issues, keep that in mind. Don't push your confidential data overseas if you're not allowed to. Otherwise, it means you can finally use it.
Yeah.
And yeah, as Jason said, the rest is new stuff, new models. Titan Image Generator is Amazon's own image generator system. So that's nice.
Bedrock supporting cross-region inference. So yeah, it's like some nice extra bits.
Yeah. As always. Okay, this one here on the networking, I wasn't quite sure what to think of it. I don't know if you read up on it, but private IPv6 addressing, which seems like a weird thing to me. Technically speaking, if you don't make it public, it's already private.
It's basically a BYO.
Okay.
So instead of, previously you could BYO your own IPv4s. Now you can BYO your own IPv6.
Cool.
And cost allocation tags. Like, if you're looking for your cost and cloud FinOps, that helps.
Transit gateway can be expensive as you pay for going in and out. Still might be cheaper to have a nice setup like that. But function level configuration for recursive loop detection in Lambda. This is really nice if you're debugging, having issues. Try to avoid recursive loops. Another good thing.
No. And yeah, more things that help if things go running away and eating up your budgets. Things that help protect that, always good thing. So, yep. So
Security.
yeah, Cognito, advanced security features. Yeah, just I had a bit of a read up on that one, detecting additional risks. So yeah, specifically they were calling out things like if you logged in from one geographic location and then you logged in from another geographic location in a time that would be very difficult to get there, it will start ringing alarm bells. So if you logged in from Melbourne and then an hour later you logged in from San Francisco, they might be questioning how you could legitimately get there so quickly. So yeah, there's just some advanced security, as I say, advanced security sort of just to detect logins that may not be legit.
Yeah. So remember, don't play around with your VPNs. Well, the other better sign-in process for the mobile app. Question: has anyone used the mobile app?
I used it once a couple of years
Are there
ago.
people who until now didn't realize that it's a mobile app? Are there people who wish they didn't know? Yeah, it's not a great experience.
It's adequate.
Yeah. On the storage side, EFS,
Faster
one of
again.
its faster things, always good. If maybe some of you will remember a couple of months ago, the whole kerfuffle about AWS charging somebody $1,000+ because his S3 bucket got DDoSed with error messages. They keep iterating on making that not so much an issue. So there's more HTTP errors that they don't charge for. Not quite sure why they don't just do all of them, but who knows? And you get additional access, additional context on the access denied error messages, so you can actually find out what's happening. Well, that's good. Conditional writes though for S3 is even nicer. This allows you basically. This was something that needed to be solved at the application level before, where you would say only write this if it doesn't exist yet. Now S3 can handle that for you, which is good.
Yeah, that's a big one. And then the air gap faults for your AWS backup. So now you're doing your backups and for some reason your account got wiped by a vendor or something, you've now got that air gap that's separate accounts, separate areas. So theoretically, if someone wiped out UniSuper running on AWS and did it, if Google had that sort of thing, then UniSuper might have been safer. But yeah, so that will protect you if your account gets wiped for some reason. If you accidentally wipe your account, backups are all air vaulted, then air gapped, then yeah, you've got some protection there.
Yep. Cool. On the DevOps side, code build got some love. Yeah, a whole bunch of new things. Nothing super excited, but new ARM-based compute types you can build on Mac. Can use GitHub apps. The thing that wasn't already, this is now that you can, lots of small
good
things.
little things. Yeah. Nothing super exciting by itself, but yeah, if you're doing these things, little things that help.
Also shows that not all products with code in the name are being cancelled by AWS without really announcing it.
They wouldn't do that, would they?
Yeah. Last things here. Bunch of small things, to be honest. I'm sure that the Connect thing is nice for some people. Workspaces of Visual Studio. I'm not quite sure what that means. As last time I checked, you can just install whatever you want.
Part of the standard bundles.
Okay. Yeah.
Yeah. So you can now just choose that as one of your the standard workspace bundles.
Yeah. And CloudFormation simplifies resource discovery and templates review in the ISC generator. That's nice. I still suggest use CloudFormer instead. Open source tool, which has a lot more love attached to it.
Yeah, last time I looked at ISC generator was not great.
Yep.
And mostly now you use like Q or ChatGPT or something to build your templates.
That's one way. And I think, yep,
That's
it for our news. So hand it back to Don.
Yes, you can use Q or ChatGPT for your templates and introduce all sorts of interesting security quirks. Now, we shall, I lost my train of thought there for a moment. We'll hand over to Lovey, who is going to tell us all about active architectures with CloudFront. Please bear with us, the streaming might take a minute to sort out. Do you want to use the laptop or laptop? Okay, laptop. It's easy. Okay, looks good. Can you hear me well? Cool, awesome. So thank you so much, Don. Hello, everyone. I am Lavi Jain, and I'm a senior software engineer at Prezi, a Women Tech Makers Ambassador, and a Google Developer Expert in GCP. And tonight, I'll be talking about setting up CloudFront for active global architecture with latency-based routing. Now, I know it's a very long title, but shortening it up might not do the justice. So anyway, I'd like to gauge the audience here. So how many of you here have heard of all the three terms highlighted in green? The CloudFront, active global architecture, and latency-based routing. If you have heard of all the three, I want you to raise your hands like this, F2 like this, or 1 like this. Okay, it's a good mix tonight. It could be interesting. All right, so the agenda is we are going to go through these highlighted terms, starting with active global architecture, then latency-based routing. We'll look at an example global service and get introduced to what is AWS CloudFront. And then we'll talk about some of the added benefits such as caching and WAF, and we'll piece it all together, address any risks, and see our final service ready. So, sorry. Is there some sound? Okay, never mind. All right, so let's start with what is active architecture. Active architecture refers to a configuration where multiple nodes, physical servers, or virtual instances are simultaneously active and operational. That means if you see these three nodes, all of these three nodes are active and they can process requests and handle traffic independently. On the flip side, the other configuration is active-passive architecture. In an active-passive architecture, only a primary resource or a group of resources are available majority of the time.
while the secondary resource or a group of resources are there running in case as a standby in case the primary ones fail or become unavailable. The main point of difference is, even though the secondary one is always running, if there's a high demand or increased traffic, it would still not receive any requests or process any requests. It will only become active or process requests when the primary ones become unavailable. You use this kind of architecture when you want to maintain redundancy and keep your system fault tolerant. But for the sake of tonight's topic, let's switch back to active-active architecture. So say you have an order processing service, and it is deployed on all those 3 instances or nodes. So when the users request your service, these requests will be distributed across all the active nodes, and this is how it promotes parallel processing. If there is an increased traffic or increased demand, you can add additional nodes to this configuration, which results in accommodating this demand without compromising the performance. And when the traffic decreases, you can scale down to the resources. So you only pay for what you use. So this way, what you get is a fault-tolerant system with efficient utilization of resources. Now, let's talk about active-active global architecture. In an active-active global architecture, we take the concept of active-active beyond individual service. So the service, along with this ALB, that becomes one single instance, and we deploy that instance in multiple regions so that each of that instance or each region becomes fully functional and independent active instance capable of receiving or serving requests globally. So if you see, we can deploy the whole service along with its ALB in Australia, US, and UK. While you can achieve it, obviously, by deploying your instances or service with the ALB, what you also need there is Route 53 hosted zone. Now, when your request will come in, it would go to Route 53, and that will decide which region your request will be served from. So before we dive deep, let's actually talk about Route 53 a bit more. Amazon Route 53 is a highly available and scalable domain name system web service. It does 3 important things. First, obviously, it registers domain names. Next, it routes your traffic to the resources for your domain. And finally, it checks the health of your resources. What we are interested in is understanding how it actually routes the traffic. So it has multiple policies available that you can choose from or configure to route the traffic. The first one being simple, as the name says, it's a simple routing policy. You just tell it, where do you want to route your traffic to, which region or which instance, and it works. The next one is failover. Now, the failover is quite similar to your active-passive configuration. So again, you have a primary resource and secondary resource, and the secondary resource will only get the traffic once the primary one becomes unavailable. The next one would be geolocation and latency-based routing. Now, I would like to talk a bit more here because a lot of people get confused between the two. So geolocation, as the name suggests, is a routing policy which you use when you want to route the traffic based on the location of your users. So say my application is deployed in Australia, US, and UK, and I am in Australia. So I would be served from Australian instance. It is quite deterministic in that regard. On the other hand, we have latency-based routing. In the latency-based routing, you route traffic to the region that provides best latency. What does that mean? So considering our example again, if my application is deployed in Australia, US, and UK, and my customer is in Singapore, and they are trying to request my service. Say there is a lot of congestion between Australia, in the Australian route. So instead of going to Australia, it would actually go to UK because the latency is lower getting that result or getting your request fulfilled from the UK instance. So it is a little non-deterministic. So with geolocation, you can actually, you deliver some location-based content. And with latency one, it is a bit non-deterministic, but it always would give you with the minimum latency. You might want to be a bit careful when using latency-based routing, because if your application can run into race conditions, then it could be a little bit of a problem. Anyway, moving on to the next one, which is geo-proximity routing. In a geo-proximity routing, you basically use geographic location of your user, your resources, with an added benefit of a bias. You can choose where you want to route more traffic to by specifying a value. Next up, we have IP-based. In an IP-based routing, you just tell which all IPs will be served from which resource. Easy. Next up, we have multi-value answer. The multi-value answer, you can actually create up to 8 records, and then Route 53 will select one of those random ones. And finally, we have weighted routing, where you can route traffic to any of the resources, but you specify a weight to those resources. So the higher the weight, more traffic goes to those resources. So actually, quiz time. I have my service that is available in 3 regions, Australia, US, and UK. And my customer is in South India, and they're trying to send a request. And they get served from the UK instance. So what do you think is the type of routing I have set up? Yes, that's correct. It's latency-based. Geographically, it should be served from the Australian instance, but given there might be congestion, it is therefore getting served from the UK instance. Cool. Awesome. So enough of chit chat. We should actually look at an example global service now. So I have created a CF demo service, and I've deployed it in 3 regions: AP Southeast 2, which is Sydney, US East 1, North Virginia, and EU Central 1, Frankfurt. Now, I want you to, and have set the latency-based routing. Now, I want you to focus on this little subdomain added, ALB dot. We are going to talk about it later. So without further ado, let me actually open that link. So I'll stop sharing and reshare other window. Okay. Yeah, all right. So if I call alb.cfdemo, this thing, it says, hello from AP Southeast 2. So I'm in Australia, therefore I'm actually reaching the Australian instance. Now, let me use a proxy, and I'll copy this URL. And let me change this to the country as UK, or Poland, France. So basically, I should be reaching the UK instance. Hello from EU Central 1. Woohoo. Proxying it again, changing the location to United States now. And it says hello from US East 1. So yay, our service works. We have latency-based routing, and it works. So that was my little demo, but we have more slides. So let's actually look at more stuff. Okay, so what is AWS CloudFront? So Amazon CloudFront is nothing but a CDN. A CDN, or a content delivery network, is a service that accelerates internet content delivery, whether it is static or dynamic content. And it does so by reducing the distance between your user and the content, or the service that is delivering the content. So if you look at this diagram, you would see that these are the stacks or the service that is deployed in Australia, UK, and US. And my user is in India, and they are trying to request my service. So they will go all the way to Australia and get their the request fulfilled. So they go to Australian region or instance, and then they come back. This round trip can take up to 170 milliseconds or so, right? But you also see little stars there. These little stars are basically delivery endpoints across the world. They are everywhere. There's so many delivery endpoints. So now, instead of going all the way to Australia, it can actually go to one of the closest delivery point to grab the content. And this time, the latency could actually reduce to 20 milliseconds. That's a huge gap, right? And say if the content is not found, it can always go back to the origin, grab the content, the delivery endpoint would actually cache it so that whenever a next request comes in, it can actually serve it from there. So this way, you actually not just improve the performance of the websites by reducing the latency, but you also reduce the load on the origin service. So some of the benefits of Amazon CloudFront is reducing the latency and reducing the load on the origin service, as we discussed. It also supports AWS origin or any custom origin. It offers DDoS protection with AWS Shield Standard. You can even pay extra for AWS Shield Advanced. Then you can get application level protection using WAF. We will actually look at a demo after this, and we can customize or put in multiple or different custom caching policies there. And it is quite compliant to security standards such as HIPAA, GDPR, et cetera, and offers secure communication through TLS. And you can actually run complex business logic closer to your customers and give them more personalized responses. And the best bit is it's a serverless function, and it scales or runs independently from your service. So it can scale up, and it would scale up independently from your service. So, okay, it's time to piece it all together. So we have already seen a service that was deployed in 3 regions, and it was connected to the Route 53. So how do we connect it to CloudFront? Ta-da! Yeah, it's not a very exciting diagram, but it works. So what we have got is, this is until what we saw earlier. And now this ALB URL, there is a reason why I had the subdomain there, because this becomes the origin for my CloudFront, while the publicly available or publicly shared URL becomes my alternate domain name, which I share with my users to call my service. And then I add a WAF in front of that. Okay, so let's actually see if this new URL also works with latency-based routing, the CF demo one. So I'll stop again and reshare. Okay. All righty, so I'm closing this. Here we are. So this is CF demo one. I'll actually refresh this. And it says, hello from AP Southeast 2. We can copy this, use the proxy again. And this is selecting the country as Poland or France. Hello from EU Central 1. And using the proxy again, changing the location to US. Hello from US East 1. So the CloudFront URL also works with latency-based routing. Okay, so now let's actually talk about caching. So consider a scenario. So we at Prezi, we sell gift cards. So we offer multiple APIs as well. One of them, or one of the endpoints is to request what all gift cards do we sell. So we would like to cache that response, which is good. We can use a custom caching policy. So this is what my CloudFront looks like. And I can create different caching policies, and I can create a special caching policy, and I can actually configure different behaviors there. So I can create a caching policy to cache my product list or the gift cards that I sell. Or then I have more endpoints for balance check, placing the orders, for discounts, for promotions, et cetera, et cetera. That means I have hundreds of endpoints. So do I go create hundreds of caching policies? Maybe not. So maybe I can create one caching policy and apply to all of them. I can do that. But the problem is that while it will be good to serve the response of the product list from the cache, I cannot serve the response of the balance checking of a card's balance from that cache. It cannot be cached. It should be real time. Similarly, if I'm placing an order, it should not be giving me a cached response. So what I do, I can actually set response cache headers in my response. And that's how I can actually have custom caching policy for each of my endpoint. So this is what I've done for one of my endpoints. So going back to this one, okay, let me zoom in. This is better. Can everybody read everything? I want you to mainly focus on this time and other things. Okay, so I'm going to just make a request just to see it's working. Yes, Australian instance, all good. Now, I've created an endpoint called cache me, and I wanted to see 168 milliseconds. It says it is cached for 30 seconds. If you look at the response headers, you would see it's cached for 30 seconds, the cache control header, and it says refreshed hit from CloudFront, because I already tested before coming here. So, but it's not 30 seconds. And see the latency now. It's 15 seconds, and it's a hit from CloudFront. It's coming from CloudFront, and the latency just reduced that low, 15 milliseconds, from I think 100 something to 15. And now again, it's a refresh hit. It's 37 milliseconds. But the point is that you can set different caching policies, and it would be so much quicker. You can serve your content so much quicker. Okay, so let's actually we were talking about some benefits. So we did talk about caching policies. So we saw that. Next one was WAF. Totally forgot it. So let's talk about WAF. So with WAF or web application firewalls, you can create web ACLs or application control lists, I think it's called. I'm just forgetting. But anyway, I've created two rules. The first rule is block by path. So if I call any random path on my application, it's going to throw me an error. Let's have a look. I'm just going to type in some random things here, and it says 404 not found. Now, this is not even reaching the application. It is coming from the WAF that I added in front of my CloudFront. And it says 404 not found, and I have a very custom message which says, Lovey says 404 not found. Now, you can set custom response bodies for your application responses at WAF level so that it looks much more clearer, or I wouldn't say personalized, but it's still much more contextual. So you can set different error response bodies. And then there's also one more, I think, for too many requests. Okay, so, and the other thing is you can actually look at a lot of logging and matrices from the WAF. So you can actually check which one of your, calls or which paths were blocked or allowed, what all happened. So if we just look at this one, I'll actually make this call again. so that I can put it in 1 minute and try. It takes a bit. I can actually see all the events that are happening, and it logs everything, all the information regarding that event. It just takes some time. Okay, so this was blocked by path rule that blocked it. And I can see all the details. Can you see actually? No. Is it better now? Yeah, okay. So you can see all the details about that request coming in your WAF, why it was blocked, this rule was applied, that's why it was blocked. You can see all the headers that are coming through. And what you can also see, what you can also do is you can redact some of the parameters. If you think there is some sensitive information in your request, you can actually redact those parameters from your logging. But you would still be able to see other things such as the URL that was called and the method that was used, all the information that you need to know about that request and why it was allowed or blocked. So it is very helpful feature to see all the things about your request. Okay, now let's actually see other thing. We were talking about the rules. So we saw block by path in action. Now let's talk about the rate limiting. If you have APIs, you definitely want some good rate limiting there. So this rule says that rate limit my endpoints. If there are 100 requests in 2 minutes, rate limit it, and if they're coming from the same IP address. So it's going to say, it's going to block it, and it's going to give me a 429 with my custom request. So let's actually do that. Let's rate limit ourselves. So we can see this is working right now. So I'm going to go to my collection and run it 100 times. Okay, so it is running it 100 run. Okay, going back. What? It didn't work? What's happening? Well, it takes about 30 seconds for the rate limiting to kick in. That's why. So we are going to keep on trying and see when it starts kicking in. Woo! There you go. It's 429 too many requests, and now we have a custom error message that we says too many requests. So it is blocked. Now, for some reason, my desktop version IP address is different to my web one. So I'm going to call the same endpoint in my web. And it says hello from US East 1. So it is blocking it by IP. So this is my web. And what did I do? And this is my desktop. So desktop still blocked, web still works. Okay, all right. Now, the last thing was about Lambda Edge. What is it? How does it work? Okay, what is your good name? Cat? C-A-T-H? K-A-T-H? Okay, Cat. Wow. Hello, Kat from Lambda Edge. So this is how you basically can run your Lambda at Edge and serve personalized content. This content, it is not coming from the app. It is actually coming straight from the Lambda Edge because it saw that there is a query parameter that is coming, and it evaluated and changed the response to this one. So this is how it is getting served. This is how your Lambda Edge can work, and you can serve some personalized content to your users. Okay, so this is awesome. So this is too good, but there is a big vulnerability in this diagram. Can anybody highlight what the problem is or what the risk is there?
users can directly access the backend.
Which backend instances? Yes. Yeah. But they need to know the URL. Like it's hard to get to the ALB URL straight away. But yes, you're partially right, because even though you have actually safeguarded this URL by WAF, your ALB URL is still accessible out there in public. People can still call it and it's still prone to attack. So how do we fix it? We fix it using prefix lists. Prefix lists are like a set of IP addresses by AWS that you can actually use in your security groups or VPC configurations, network ACLs, and you can actually lock down your stuff. They're pretty helpful. They're also called asplists. So here we have a plist for CloudFront, and I can actually use it. So let's actually do that. Let's protect our ALBs. Let's protect our ALB. Before we do that, I have to show you something. So you remember my old ALB URL, right? This is the where am I, which is good. Now I'm going to call it at the root level. I have got hello world there. Now, when I created the WAF rule block by path, I did not include the root there. So if I call my actual public URL at root, that is protected by WAF, it's not gonna work. But my ALB one, it still works because it is not protected by anything. So we want to protect it now, and we would do it by adding a plist to the security group of the ALBs. So this is my ALB, and this is the security group. I'm gonna go here and edit the inbound rule. Can you see my screen well? I think so. We are going to allow all traffic from CloudFront only and nowhere else. So allow from CloudFront and save the rules. And now if I try to call this endpoint again, I don't know if you can see that, but it's still loading. It's not going to come up. It's still loading. So ta-da, you have protected your ALB now. So I'll stop sharing and reshare. Okay. So yay, that worked. We protected it. It looks really solid, looks really good. However, when it comes to deploying these kind of services and this architecture, you need to be really cautious because you need to be thorough with your use case. What kind of global service are you trying to create? What kind of experience you're trying to give to your users? What kind of data are you handling with? Is that global? Is that siloed? For example, if your data is siloed, say the customer data of your Singapore customers is only available in Australian database. And if you configured latency-based routing and it went to UK, it won't be able to find the data for your customer. So you might want to be much more deterministic there, or maybe use global tables, such as DynamoDB. Or you can actually have better data consistency, either eventual or strong. And then, as I mentioned earlier, if your application can have race conditions, then you might want to go with more deterministic approach than the non-deterministic one. And then finally, increase costs and efforts. Such kind of infrastructure includes lots and lots of costs because you're not running multiple containers, but you're running it in multiple regions. And you would not be configuring that just for one environment, like not just for production, but also for staging, testing, development. So many environments, so many configurations, and a lot of costs and a lot of developer efforts. Plus, there is so much of development caveats included. Just to name a few, when I was creating the WAF, the log group for the WAF, I did not know that it needs to start with AWS WAF logs. So I struggled a lot. Then there was with the CloudFront, you can only use certificates from US East 1. And IAM permissions, they're always there. So, oh my God. But anyway, If you do not like the whole thing, there are alternatives for you. So you can actually use integrations at the ALB level itself and configure WAF at the ALB, or you can use in-memory caching. Or there's another thing called as AWS Global Accelerator. You can use it to direct traffic over the AWS global network to static IP addresses that serve as like fixed endpoints to the nearest region to the client. And they only are good for routing. So it might come down to on your problem that you're trying to solve. So for example, if you just have one ALB, you might be good doing this. If you have multiple ones, you need a single domain name, then consider CloudFront. There could be another problem where, say you went with this kind of an architecture, but then you later decide, oh, I want to serve some of the content from S3. How would I do that? If you have CloudFront, you can actually have a separate origin under the same domain name with a different path. So there are different scenarios that you can consider to choose your solution or design your solution. Finally, what we have got is a active global service deployed in 3 different regions with latency-based routing. ALBs logged with prefix list. CloudFront set up with origin and alternate domain name with Lambda Edge, custom caching policy, WAF. And finally, we have reduced latency, high security, rate limiting, custom caching, reduced load on servers, DDoS protection, firewall, and personalized edge response. So thank you. Thank you so much. Any questions? Yes.
DDoS with the asterisk, what's the small print?
Let us get you a microphone.
Oh yeah.
You had DDoS asterisk. What's the small print?
If you go onto their website, you would realize it's you get DDoS protection, but you get it as a standard protection. If you want advanced, then you pay extra. That's why I had a little asterisk.
So how do we determine what objects to cache? I understand the real-time transaction things can't be cached, but how do you determine
What to cache?
yeah.
I think it definitely depends on your use case, but most likely if there is any content that does not that does not change over time enough, then you can simply serve it from cache. Like
Static objects.
yeah, more of those. So for example, as I mentioned with Prezi, we sell gift cards, right? So we won't be adding a new SKU every second. We won't be adding a new gift card every second. It might get refreshed like in a day or so, I don't know. But you can simply give it from the cache because it is not updating real time.
Thank you.
No other questions? Cool.
Okay.
Then
Thank you, Lovey. That was probably the best description of Route 53 routing that I have ever heard, and a really good, solid introduction for anyone who wants to build a website. That should be your reference point. Now, for something completely different. Mr. Matt Merrill, one of our organizers, has been trying to build an R2D2 bot. Shall we hear about how it went?
How it's going.
Welcome, Matt.
All right, 1 minute here while I do the Zoom thing. Where did I put those numbers? And don't say the password out loud because that would be silly. Oh, right, connect to internet first. That's why I can't find it. Why can't you find my phone? Come on, I was literally just connected to you a moment ago.
Technical difficulties with the Wi-Fi, please stand by.
Boom, boom, boom. Boom. What are we doing?
Daniel, we might need your assistance. Let's see if we can get
That's
you
all
on
right.
now.
That's all right.
Oh,
All good.
you managed to get it working.
Yep.
Okay.
Turns out if you disable hotspot on your phone, then you can't hotspot to your phone. See? We're learning. And that's what nights like this are all about. Do not join audio. We do not need that. Share screen. Share the whole thing. All right. And move that out of the way. Where is Mum? And how do I hide? I could go away. Easy done. All right, excellent. So let's start off with the easy stuff here. Who likes Star Wars? Almost everybody. Cool. Who doesn't know what Star Wars is? And some people might think that that's a funny question, but it actually turns out my boss at work legitimately did not know the difference between Star Wars and Star Trek. So I've been telling him for months that I've been doing this project, and he's just been having absolutely no idea what the hell I'm talking about. And that's okay. I realized after I was writing this presentation and then realized that I kind of ruined the punchline to this in the title of my presentation, but that's okay. Who is the best Star Wars character? It is R2-D2. The answer is always R2-D2. All right? And because R2-D2 is the best character in the Star Wars universe by far, we are going to build one. Or at least that was the idea that I had. Today's session is going to be a little bit different for the user group because the first, I don't know, half of the session is going to be taken up with not AWS stuff. It turns out that when you're talking robotics, you kind of need to talk about a lot more than just what the cloud does, particularly seeing that, well, the robot's not always connected to the cloud. So, problem. We'll go through the physical aspects of building a robot, the software aspects of getting the robot to do things, where AWS does fit into the picture, and what I'm currently using it for and what we're going to use it for in the future. Look at a few lessons that I've learned along the way, and then where we go from here, because you will see that there is still plenty to do. I will try and rush through all of this. I think last time I ran through this presentation, it took like an hour, so I'm not going to hold you here all night. We'll get through it as quickly as we can. For those of you who don't know me, I am Matthew Merrill, Principal Consultant at Mantel Group, based here in Melbourne. I am an AWS Golden Jacket holder. I'm an AWS ambassador. I'm a community builder, and I'm an organizer of this user group. All that is a fancy way of saying I do a lot of AWS. It turns out I am not a robotics, mechatronics, electrical, mechanical engineer, and all of those aspects and skills are really important when it comes to building robots. The AWS stuff, not so much. Yeah, no. So this is just a way of saying, well, I do know a lot about AWS. I actually don't know much about the topic I'm talking about tonight, so don't listen to me at all. I have absolutely no idea what I'm talking about. but we're going to do it anyway. And I decided many months ago, in fact, I decided like 18 months ago that I was going to build one. And like most of my projects, I got very excited and started, and then life got in the way, and various things happened, and work expect you to rock up and do stuff, and I had a child, and then and then a couple of months ago, I was talking to the organisers of the Builders After Dark meetup over at the AWS Builders Studio, and they said, "Why don't you come in next week and show us the robot?" And I went, "Because the robot's not finished." And they went, "Well, okay, how about you come in August? That'll give you 10 weeks. You'll be able to finish it in 10 weeks, won't you?" And I went, "Yeah, absolutely." Two things with that. One, no, robots take a long time to build. And we will get into a couple of reasons why. And secondly, it turns out life gets in the way as well. But, these things happen. So as I've sort of been getting closer and closer to this date, I've sort of been thinking, okay, this is a side project. This is a thing that I'm doing in my spare time, what little of it that I have. What are sort of the milestones that we can sort of set? And even if it's a failure, we can still call it a win. All right. For anybody who watches Void Star Labs, Zach Friedman on YouTube, he's a big supporter of the just get it done. Doesn't need to be perfect. Doesn't need to be spick and span. As long as it's got like one feature, a finished project is just a learning that you can apply to future things going forward. So I was sort of thinking, well, what can I carve out and make this sort of like an MVP? Okay, well, if I just build the droid and it doesn't have any robotics in it, it's still a cool thing to have in the corner of my office that people can look at during video calls. That's still cool. Not as cool as a robot, but it's still like, a thing, right? I can still call that a win. I've got a droid. It just doesn't do anything. All right, well, if I get to that point, what would the next logical step be? Well, we can make it drive around, articulate its doors, open its flaps, make noises, do all of that sort of stuff. I can basically turn it into a remote control R2-D2. There are plenty of those around, and that's still pretty damn cool, right? Having a remote control full-size R2-D2 zooming around the house, yeah, that sounds like my idea of fun. We can do that with an Arduino. There's open source projects on the internet with wiring diagrams, source code, the works on how to do exactly that. Probably should have done that, but I didn't. Because I thought about it and I went, well, if you can do that, then wouldn't it be cool if it could do all of that, but autonomously? Because if there's anything better than a remote control robot, it's an autonomous robot. The problem is you can't build an autonomous robot on an Arduino. Not enough grunt, not enough go. So I decided to skip step 2 and go straight to step 3 and build the thing with Raspberry Pis, for which there isn't heaps of source code freely available on the internet, and there aren't wiring diagrams galore, because I'm an idiot and bit off way more than I can chew, hence why there is no R2-D2 sitting there right now. The reason I wanted autonomous is that I have milestone 4. This is if everything works to plan, this is what I sold the boss when I said, hey, boss, I need some money and some time to do this project, and this is what it's going to do. And the boss went, that'd be awesome. Yeah, let's do it. Yeah, we're a long way off that. The dream is to have R2 sitting in our office so that when it comes to Friday night drinks, if we think episode 6 on Java's Barge, he's got the drinks tray around his back as he's enslaved, have him drive around the office with drinks and be able to identify people that don't currently have a drink in their hand, drive up to them and beep at them so that they can take one off the tray. When the tray's empty, he knows to go back to the kitchen to get more. All right, well, that's just robot with image detection, navigation, self-driving capability, stock awareness, situational awareness. Yeah. Not to mention I still need to build the damn thing. So, okay, if that's milestone 4, that's what we're shooting for, right? And anything between here and there is going to be a win in some way, shape or form. Where do we get started? For those of you who are insane and want to do this along with me, astromech.net. VB Bulletin site. filled with, thousands of people around the world who are just as crazy as I am, and build their own R2-D2s or astromechs for fun. You want an R2-D2, build an R2-D2. If you want one of those little mouse droids that go driving around the Death Star, you can build one of them. You want a BB-8, they've got plans, diagrams, the works. Everything from how to build it out of polystyrene, balsa wood, carbon fiber. These guys do it all. They've got designs for all the different customizations. You want the bad motivator scene where the little bit pops out of his head. You want, Luke Skywalker's lightsaber in there that pop out, and all of those sorts of things with compressed air canisters. Yeah, these guys will help you design it if it hasn't already been done. And chances are it has already been done. Someone has done it or is in the process of doing it. The one thing that they haven't done is build a cloud-enabled R2-D2 based on Raspberry Pis using rods. And I think there's a reason for that. But, if you're sensing a theme, yeah. So when I first started the project, I went to astromech.net, I signed up for an account, started looking around, got a whole bunch of information, and went, all right, cool. What are we going to build this thing out of? Aluminium. Way too expensive. Durable, yes. Will last, yes. Very expensive. Polystyrene is another really common material to build them out of, but not very durable. Carbon fiber, well, no. Fiberglass is another really common material, but I'm already having to learn like everything. I'm not learning how to do fiberglass at the same time, right? That's a step too far. So then I sort of came along and went, 3D printing. A 3D printed R2-D2, right? Like that sounds like a happy medium. I have a 3D printer. 3D printed items can be quite durable. They are relatively cheap, and plastic's not, terrible. 3D printers are about as expensive as you want to make them. They start at a couple of $100s and they go up to tens of thousands of dollars. Pick somewhere, with your price point and go for it. And they're relatively easy to work with, depending on the type of plastic that you choose. Obviously, some of the more exotic plastics are harder to print with and may or may not put off carcinogenic fumes and but we can be tactical about what sort of plastics we pick. Now, I think 3D printing, great, fantastic. It turns out there is actually a guy, Mr. Badley. He's a member of that Astromech forum. He had this idea a long time ago that 3D printed droids would be a really cool thing. So he actually opened up a copy of Fusion 360 and decided to systematically design every single part for an R2 in Fusion 360 in such a way that they will all be 3D printable, because if anybody's done any 3D printing, you know that just because you can draw it doesn't mean you can actually print it, because, you build a layer on top of layer, so you can't print over the top of air and all of these sorts of things. So he went through and systematically designed every piece and mounting holes and, okay, well, if we fit this bit, then it's going to need a screw hole here and a screw hole there. And he's broken it all up and it's all there. All he asks is a $5 a month Patreon subscription. And I took one look at this and went, take my money. You know what? Take it, charge a whole year in advance, right? Like, there is no way on God's green earth that I'm going to be able to do anything close to this. And it's just there, freely available, ready to go. So it's like, right, done, easy. That's the print. So now all I've got to do is open up every STL file, of which there are a couple of hundred, and just send them to the printer, and Bob's your uncle, done, right? Simple. First of all, get yourself a better 3D printer, because I had a little Ender 5, and this was only going to take about 9 months of non-stop printing 24 hours a day on that machine, because it's pretty slow. So I got myself a better 3D printer. For those of you, again, not playing in the 3D printing world, this is a Bamboo Labs X1 Carbon. I bought it last year. It is, in a lot of people's opinion, the Rolls-Royce of 3D printers. Built by a bunch of people, the Bamboo Labs started by a bunch of ex-DJI engineers who went, hey, what if we took that sort of logic and applied it to the 3D printing world? It is incredibly fast. It is basically the Apple of 3D printers. 3D printers are known for being hacker friendly, do it yourself, build it, hack it, change it, do it, make it do things that you want it to do, make it go faster, make it, do multicolor. Yeah, you can't do anything with this machine. It is as closed source as it gets. But what it does do really, really well is if you send it a file and say print, it will do it. And it will do it again and again and again, and it is reliable. I think if you exclude the me mistakes, I've had 3 failed prints in 2,500 hours of printing from this thing. It has been rock solid reliable. And it just sits on my desk in my office behind me while I work all day. I think it's noisy because I'm the one sitting next to it, but the people on the other end of my Zoom and Google Meet calls all day can't even hear it. In fact, if I'm sitting in front of it, like not leaning in the right way, they won't even know that it's running unless I lean and they can actually see the print head moving around. Super cool. If you don't have the $2,500 that this thing costs, Prusa's do good printers, Cobras do good printers, and Solvo's are doing some really nice stuff with their new Gen 8 printers, just in case you want to, play along at home. The one problem with Bamboo Labs and a lot of the others, a full-size R2-D2 body is about 485 mil wide. That printer, its print bed, is only 256 mil wide, which means R2 no fit. That's okay. We can cut the pieces up and then glue them back together again, and voila, now we have, full-size parts, but it is more work. And if you, again, 3D printing little tip, yeah, just because it's 127 mil does not mean that it's going to come out perfectly at 127 mil when it prints, because plastic shrinks and warps and does all these really weird things, Yeah, so it can be a little bit hit and miss. It requires a lot of sanding and a lot of prep and a lot of fun. So yeah, just keep that in mind. We've got a really good printer. Excellent. Next thing we need is some filament to print with. Look, long and the short, this is not a 3D printing user group. This is an AWS user group, so I'll sum it up really quickly. Don't cheap out on filament. Just because Amazon has filament going for $15 a kilo does not mean that you should go and buy a bunch of it. You get what you pay for. If I run cheap filament through my printer, it will fail. It will have problems. It will spit. It will splatter. I will not get good quality prints. $20 a kilo seems to be about the break point in Australia for decent filament. I use eSun, and with the exception of the first few rolls I got when they moved over to cardboard spools, history lesson, most 3D printing filaments used to come on plastic spools, but recycling is a bit of an issue when it comes to those. So most manufacturers have now moved over to cardboard spools for obvious reasons. The problem with eSun is when they moved over to cardboard, the glue that they used to stick the spool together would actually stick to the filament. So you get about 80% of the way through the roll, and then the filament would be stuck to the cardboard and your printer would jam up and you'd have all sorts of problems. That seems to be fixed now. Other people have said that eSun is rubbish and they've had nothing but problems, but as I say, I've had good times. Polymaker, really good, but is about another $10. So that's about $30 a kilo, more expensive. Elegoo, hit and miss. And Bamboo now do their own. If you buy it in 10 spools or more in a batch, they'll actually do it for 21 kilos with free shipping. So that's actually currently the cheapest option for good quality filament. The fun thing about Bamboo Labs is each spool actually also comes with an RFID tag, which will pre-configure the printer to the right temperatures and feed speeds and all of that sort of stuff based on the material. So you don't have to go in and say, this is eSun PLA, which has a melting temperature of 225 degrees and a feed speed of blah, 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 blah. Again, 3D printing. Nonsense. Other physical things. Nuts, bolts, screws, washers, magnets, bearings, threaded rods, like just all sorts of stuff. The answer is the internet. Lots and lots of time on the internet. Do not go to Bunnings to get your nuts and your bolts and your screws. For what it will cost me to get 8 M4 bolts from Bunnings, I can buy 100 from the fastener factory in Oakley. So considering that this robot, by the time it's finished, is going to have about 220 bolts in it, that is a huge price difference. Mechanical components, motors, more motors, dome lights, and lots of servos. By the time R2 is finished, he is going to have 34 servos and 3 motors. AliExpress is a great website. You can get some really cheap stuff on there. You get what you pay for. I got a whole heap of SG9 servos, which are the really little 9-gram servos. They articulate to about 180 degrees. I got 16 of those for $23, whereas a servo from like an RC shop, like a hobby shop, would cost me like $25 each. Yeah, the ones from AliExpress, I got 16. About 6 of them didn't work out of the box. Another 4 of them failed pretty much as soon as I applied power to them. There's a little bit of a debate as to whether or not that's the servo's fault or mine. And they're entirely made out of plastic. So as soon as you put them under any real load, or let's say you put the rod in backwards and fed it, so it's trying to pull when it should push, it's put it under a little bit too much load. The motor burns out, and now the damn thing's useless. While you're learning, you're probably going to kill some servos. So, but spending $23 for 16 of them is probably not a bad idea. But I will tell you now, none of those will be in the finished version of R2 because I will not have any working ones left by the time I get to that point. I presented a similar talk last night at the Builders After Dark. There was a fellow presenter there, Adam Purdy, who is a senior solutions architect in the AWS robotics team. He builds the little robotic spiders. He was talking about Stephanie, one of his spider models, that has 24 servos in it, and they are $30 each. Because if you want good servos, they cost money. So, R2 is going to cost me a lot of money by the end of this, as it turns out. Tools, you really don't actually need a lot. That's all the tools that I've used to build R2 thus far. Not even a soldering iron. That crimp has gotten a lot of use, but I haven't had to use a soldering iron yet. Super glue, spray paint, sanding paper, filler, so much filler and bog. It is the greatest thing because it will hide mistakes. It is also a pain because, building robots is nothing like software development. All right. If you need to build something in software land, you just stay up and spend another couple of hours coding, right? Like that's what you do. The end of the sprint's coming up. Yeah, you go into crunch mode. You work the weekend. You get it done. Come Sunday, git commit, git push, done. Yeah, it turns out when, spray paint and then wait 3 days for it to dry and then sand it because it ran and then spray paint it again and wait another 3 days and then realize that it needs some filler and some bog. So you put that on there and then wait 3 days for it to dry and then spray paint and wait 3 days. And does this sound like a waterfall project or what? There is no way really to speed that up, especially when it turns out that spray painting inside your workshop that has very limited airflow isn't a good idea. And you very quickly, even with an ultra high quality respirator, very quickly go, why can I taste paint? Need to spray paint outside. But when you live in Victoria and the weather is, Victorian, spray painting takes a really long time. One of the many reasons why he's not here. That's just a really interesting side note of, robots are waterfall. They're not agile, they're not Scrum, they can't be solved with just more effort. This is what I was talking about before. This is what I should have done. This is what the inside guts of R2 should have looked like. All right? There is a GitHub link there with all the code, wiring diagrams, the works. The Mr. Badley even comes with that mounting board. So I could have printed the whole thing and be done. As I said before, it runs on an Arduino. It has a 16 megahertz processor in it with 256 KB of memory. Obviously, we ain't doing nothing autonomous with that. So we moved to the land of ROS. Robot Operating System. It is a fantastic open source resource. It has everything you've ever thought you might need or didn't even know you wanted or needed in order to build robots. It's not an operating system. Just ignore the fact that 2/3 of its name is operating system. It is not an operating system. It is a bunch of applications. But hey, you know. Also, it looks incredibly intimidating because like there's all these different versions and all of this sort of stuff. It's actually, there's a lot of good resources on the internet, and I've got a link at the end to some of them. The problem with ROS is it follows the Ubuntu release cycle. So they do a bi-yearly LTS release, same as Ubuntu. And Ubuntu and Windows 10 are the only two supported operating systems. So that's a problem because, yeah, I don't run either of those. Red Hat's what they call a level 2, which is it should work, and if it doesn't, we'll get to it pretty quickly. But, you know, that's not a guarantee. Everything else it's a C application. You could compile it yourself. It should work, maybe. That no work for me because I use Arch, by the way. So that's easy. I need a development environment running Ubuntu that I can custom load some stuff into. That sounds like a perfect use case for AWS Cloud 9. And then they discontinued it. So we're not going to do that. I'd literally just spun my environment up the day before they announced the dev. And one of the points of this project is to teach people how to do this going forward, which is fine because I would have already had the account so I could provision Cloud9, and they've said it's not going anywhere, so I could have done it. But teaching other people how to use a product that they can no longer get felt a little silly. So we're going to go with VS Code Dev Containers instead. For those of you who haven't played with Dev Containers in VS Code, seriously take a look at it, especially if you're a consultant working for multiple customers. The idea of being able to have per project effectively instances of VS Code with its own extensions and its own settings and its own UI, is phenomenal. It basically just lets you run your entire project in a container. So you can have everything customized for that particular project, and then you open another project, open a different container. It has completely changed the way I do software development now, because you have your list of base plugins, and then you've got your per container plugin. It's phenomenal. There's an entire session just on VS Code Dev Containers, which actually works really well because, you can go new containers, you can add extensions into containers and all those sorts of things. So what that means is effectively that I can run ROS in my dev containers. I can do all of my dev in there. A quick 30-second side on ROS. The long and the short of ROS is it's basically a bunch of message buses, right? It's topics, it's pub sub at its heart. That's how it works, right? You've got nodes, which are the individual components of the robot. They can send messages to topics. You've got other people who subscribe to topics. This is, SNS, SQS stuff, right? Like that, just think of it like that. You've also got some, things like services and actions, which are like, I don't want to just publish this and have it happen eventually. I want you to go forward. I want you to turn. I want you to stop, and I need you to do it now. Or like, I want you to do this and let me know. Like, I want you to go over there and let me know when you get there, sort of stuff. Again, fundamentally, it's all just topics, and that under the hood, it's just how it sort of handles it and how it passes it through. But effectively in R2, which is comprised of 3 Raspberry Pis, this is all that's happening. It is just a whole bunch of containers sending and receiving messages to different topics, right? So I have, for example, my battery monitors. They're monitoring the current and the voltage on the batteries. They publish to topics so that I can have other things listen, and when it gets to a certain point, it can go and do something. I've got Docker containers that run the code to drive the motors. Other parts of the robot can send a message to that Docker container and say, hey, go forward, turn right, go over here, whatever the case may be. That's all great. So I've just got a whole bunch of messages and topics and things going around on the robot. How do I actually get that into AWS? Because ultimately, as I said before, what I want is I want it to be able to deliver drinks around the office. In order for it to do that, I want it to know things like, that is Jason. Jason likes that type of beer. So I'm going to take him that type of beer. Oh, we don't have any of that type of beer in the fridge because I'm going to need stock of. So it's going to need to be able to communicate with AWS for a bunch of things. Greengrass is the answer to the question. So For anybody who's played with AWS IoT, like at all? Yep. Played with Greengrass at all? Yeah, Greengrass, that's a rabbit hole and a half. The AWS IoT suite, for those of you who haven't played with it, is a little bit of a different being to a lot of the other AWS services. It is a hell of a lot of work to even get like a hello world up and running, because you've got to do certificates and trusts, and you create things which are like the actual IoT thing in the world, and like there's a whole heap of stuff. It is incredibly rabbit holey. There's a lot to do, but once you get it up and running, it's sort of, again, it's all based on topics and messages and queues and that sort of stuff. So all we've really got to do here is on, again, R2 on the main Raspberry Pi, brand new Raspberry Pi 5, is the master node of ROS, which is the one that's managing all the topics. Also has another container running Greengrass, which basically listens to all of those topics and replays them up into AWS. All right, so now in AWS, I effectively have a shadow of all the messages and things that are going on the robot. At the moment, I'm pumping everything up there. I am sure that will change over time because it will just be too much damn data. At the moment, this is a POC on my desk at home on my local Wi-Fi. As soon as I hook R2 up to like a 5G connection and actually have to start paying for data, yeah, I'm probably going to pull back. I probably don't need every single message that's flying around this thing being sent into AWS. So I'm sure that will change. And that's fine. You can do all of that in the IoT, in the Greengrass config. What this also gives us, because if we've got containers on a bunch of Raspberry Pis in R2, as I said, there's 3 Raspberry Pis. There's one in the dome because the dome has the head. So it's got all the lights, it's got the flaps, it's got the holo projectors and all of those sorts of things. Without going down too much of a rabbit hole, R2's head spins full 360, all right? That means you need a slip ring to run the cables through so that the cables don't get bound up, right? Because you want his head to be able to spin in one direction forever, right? So you need a slip ring. That's got metal brushes in it. Metal brushes can only carry up to a particular current draw before you go fire. And because R2 is made of plastic, melties, so there's only so much current you can pull through those wires. Now, in my instance, because I've spent my money on other things, I can only pump 2 amps through those wires. Now, there are 12 wires, which means I can run 2 amps through a couple of them. But effectively what that means is I need to pump it through at a high voltage at 2 amps and then drop it down to the 5 volts that the servos need, all in the dome. So that means I've got to have the logic, the controllers, and all of that in the dome together, which is why there's an R-Pi in there. The other 2 Pis are in the body. One drives all the motors and the doors and the flaps and the utility arm and all of that, and the other is the master node. So I've got 3 Raspberry Pis, all running a myriad of Docker containers, because every servo runs its own Docker container, every motor runs its own Docker container, bunch of reasons, security and and we can go down that topic a different day. And now I've got my Greengrass Docker containers as well. How do you do deployment onto local machines when, well, the robot's not on 24 hours a day, isn't always connected to the internet? So standard, git commit, git push, CI/CD pipeline run, job done doesn't really work. You need something like this. This is an older version because this is my personal project and haven't had time to finish the whole, draw diagrams thing. But basically what it is, and this is sort of the better diagram. This shows you what I've sort of been building. This is a reference architecture for effectively self-driving cars on AWS. This is a component of it. But what it means, or what we effectively do, is we use this little bit over here. Remember how before I said with IoT, there's a whole heap of stuff that you've got to do just to make it work? Yeah, all I want is to use Greengrass, because Greengrass will actually coordinate the deployments of your Docker containers on your things for you. It does over-the-air updates and all that sort of stuff. Yeah, out of the entire diagram, that's the bit that actually does the over-the-air updates. Everything else is just to make it work. But Greengrass will now allow me to simply do my git commit, git push for my code, have it land in ECR, and then Greengrass will pick up the new configuration, package it up as a deployment, and push it to all of my Greengrass devices, which in this case is the 3 Raspberry Pis on the local machine. In the robot. Fantastic. That now automates the deployment, because logging onto 3 Raspberry Pis and doing manual pushes and all of that sort of stuff is really time consuming. Shouldn't have done it as many times as I did. So that's great. We can now get the code to the robot, right? So we can push our Docker containers to the robot. The robot can now talk back to AWS over Greengrass, which means we can now actually start inserting all of this other AWS goodness in there. So the plan is, again, right, because this is all work in progress, we are running analytics because, again, if we're serving people drinks and all that sort of stuff, it'd be nice to know how many drinks we've served them, how many people we served, et cetera, et cetera, et cetera. So we want to pump a bunch of data up into AWS, do some nice, pretty, data metrics and all those sorts of things. I, from an engineering standpoint, also want to know things like temperatures, current draw, how long does R2 run between having to be charged, and all of those sorts of, engineering questions. So we need to pump a whole bunch of data back into S3 and into a data lake so that we can do some analytics on that. As I mentioned before, we're going to have things like, what drinks we've got, et cetera, stored in databases. We also have some AI and some ML because we need to teach this thing to drive at some stage. Once I finish building the physical thing, and once we get over the servos not working and needing to finish writing all of the code, which is C, and I don't know C, and all of those other bits and pieces, we need to teach this thing to drive. All right. ROS. Remember how before I said that ROS has everything you possibly need to know about need for robots? Yeah. RViz and Gazebo. These are how you virtually build and train your robot to do things without physically having to build it. So you can actually design up an entire R2-D2 in Gazebo and tell it, right, here are your legs. Your legs, have motors which will drive you forwards. They're connected to your shoulders. Your shoulders are connected to your head. Your head can spin on this pivot point because there's a motor there. And you can actually articulate all of that in what's called a URDF file, and then use that because that will then be a virtual representation. So when you run your code, you actually point your code at Gazebo, and rather than it driving the physical servos and motors in your robot, it will drive the virtual ones in your Gazebo implementation. And this is how you simulate your robot. Now, it turns out, this I did not know when I first started playing with Gazebo. And again, remember the whole I don't know what I'm doing. You don't actually need to draw the robot yourself using rectangles and spheres and cubes and all of that sort of stuff, because Gazebo supports meshes. And for those of you who haven't played with 3D printing, yeah, that's called an STL file. That's the file you send your 3D printer. So all of those Mr. Badley files that I got to send my 3D printer to print the parts, it turns out I can import them directly into Gazebo and use them as, oh, by the way, here's the robot. So there's like 30 hours of my life that I'm not getting back, because I did way too much of that before I found out that STLs are a thing. But yeah, it means that you can design your robot in there and then use Gazebo to simulate environments. There is a thing called in ROS that we can use for navigation, self-mapping, all of those sorts of things. We can run this in RoboMaker. RoboMaker allows us to simulate worlds. NVIDIA does some brilliant work on virtual worlds where we can then run simulations using RViz and ROS and teach it how to navigate the world. So NVIDIA will effectively project a simulated world. You run, Gazebo will run your navigation code using the model that you built in RViz and navigate around that world, and you will see what happens. The idea here being this is effectively the mechanism for how we teach the robot to drive and to navigate. If we wanted to go super crazy and, over-engineer our model and over-target it to a specific use case, I could simply just build the Mantel office in Isaac and only train it on that one location. And it would be able to navigate the Mantel office brilliantly, but would be completely screwed if I sent it anywhere else. Joys of machine learning. This is a hell of a lot of compute. But RoboMaker takes care of all of this. Simply all you do is you give it the ECR container that runs, in this case, Isaac. You point it at your code for ROS, and it will meld the two together. It will run the simulations. It will spit out the results to CloudWatch, and off you go to the races. That's as far as I've gotten thus far. All right. There's a lot of in progress. Robotic projects, as I said before, are waterfall. This takes a lot longer. It's a lot more work than I anticipated. I will be here for a lot longer, but that's okay. I've got listen to Adam here. Again, I mentioned Adam. He was the other presenter last night. When I spoke to him last year and said, hey, here's a cool project I'm thinking of doing, his immediate words were, that's a really cool idea, but why don't you actually think about doing something a little bit smaller as your first project? Why don't you bite off a little bit less so that you can like learn these things one at a time? I went, yeah, nah, we'll be good. How hard can this possibly be? It's just robotics. Yeah, Adam was right. When an expert tells you something, you should probably listen. But it's still fun, right? Like I'm bashing my head against a brick wall with this stuff. Everything's taking longer. Everything's more expensive than we anticipated. But it is still a hell of a lot of fun, right? What's next? Finish the build. Finish learning C so that I can finish the ROS packages so that I can actually get the robot to start doing things. And whoops, I haven't updated that one. Actually finally bring him to the user group. What does he currently look like? Where is he? What status is he currently at? This is him as it currently stands yesterday. So the body is now built. The head is built but not finished being painted. The insides work. The Lazy Susan's all there. So the gears for turning his head and all of that sort of stuff work. The mounts for the batteries are all now in. And I have mostly printed the parts for all of the electronics. There is a QR code there for people if they want to get the references, the links, and all of that for anything. And you can also get status updates on how I go. Any questions? I know we've gone very much over time. I will be here for a little bit. If people have got questions, you can come grab me.
Yeah, I'm actually going to ask, given that we are over time, that we hold questions and we do that in the hallway track. Otherwise, marketplace, is there anyone here who is hiring, who wants to do the elevator pitch? No? Then I'm going to call that the end of another Melbourne AWS user group meetup. We can skip the marketplace again because we're over time. Thank you, everyone. We will see you next month. And thank you, Matt. That really was something completely different. Oh, and by the way, please take out the food.